Now we saw in the previous section that the divider-chooser method is a very common fair division method for dividing up a continuous asset. However, that method only works when there are only two parties involved. So when there are more than two parties involved, we utilize a similar method known as the lone divider method. So for this example, we're going to be using the lone divider method for 3 players. And it says, 3 friends, Mo, Larry, and Curly, are dividing up a set of assets, S, into 3 shares. The shares are labeled S sub 1, S sub 2, and S sub 3. The table shows how each friend values the individual shares. Determine a fair division of the asset S for the friends using the lone divider method for 3 players. Now, the lone divider method is pretty much exactly as the title states. There's a single lone divider, and then the other players are the choosers. So we have this table here. Here are our three players, Mo, Larry, and Curly. You can see that Mo values share 1 at 35%, Larry values it at 50%, and Curly values it at 33 1/3%. Mo values share 2 at 35%, Larry at 30%, and Curly at 33 1/3. And for the final share here, share 3, Mo at 30%, Larry at 20%, and Curly at 33 1/3%. Now we can see that Curly is the divider for this particular asset here. And we know that because each of the shares is broken up evenly. He broke it up into 1 over n, and n is the number of players. So he broke up those shares into 1/3, and 1/3 is 33 1/3%. That's how we can tell who the divider is because their shares are going to be even, because they're going to be the last one to be able to take a share. So no matter which share they choose, they'll always get a fair share. And what would be a fair share? Well, at least a 33 1/3% worth of the asset. So as we look at the table here, the only fair shares to Mo are share 1 and share 2, both at 35%. Don't forget, Mo expects to get at least 33 1/3%, so these are fair shares to Mo. The only fair share to Larry is share 1. So it seems as though, since that's the only fair share to Larry, Larry's going to have to get share 1. So I'm just going to circle it. Therefore, Mo will have to get share 2. And then Curly gets what's left. And of course, that's share 3. So fair division, according to this table here, Mo gets share 2, Larry will get share 1, and Curly will get share 3. Now let's take a look at this table here. It's the same idea. We have these 3 players and we have these shares divided up. Again, we can see Curly is the divider. The fair shares to Mo are share 1 and share 3. And the fair shares to Larry are also share 1 and share 3. So if we were to give share 1 to Mo, then we would have to give share 3 to Larry. And of course, Curly would get share 2. However, we can see that Mo could possibly get share 3. Therefore, Larry would get share 1. So both of those divisions are fair divisions. They both work. If Mo got share 1, Larry got share 3, and of course Curly gets share 2, that is a fair division. However, notice that there is better value if we divide it this way. Mo gets share 3, Larry gets share 1, and Curly stays with share 2, because it's a higher value. If Mo gets 34% rather than 54%, well, that's still a fair division, but this one is better. So these 2 players would probably talk to each other and maybe discuss what they would want to do, and they can decide to swap out. So both of the divisions are fair divisions, but we're going to be looking for one where they both benefit the most. That way they're the happiest. So this is known as an optimal division, and that's what we're going to be looking for. We're going to be looking for an optimal fair division. Even though both of the ones that we showed where Mo gets share 1 and Larry gets share 3, that's also a fair division, but this one kind of works out better for all players involved. So we're going to stick with that. So we're going to be looking for an optimal fair division. But there we go.